Hello everyone. In this lecture, we will study about a tabular column method or Quine Mcklausky method. So we already have seen what is K-map, how to solve a Boolean function or minimize a Boolean function using K-map. That also we have studied 2 variable, 3 variable, 4 variable K-map. So what if the variables goes on increasing, then how can we minimize the Boolean function? So for that, for the solution of this, we can go for Quine Mcklausky or tabular column method. So here we can see some the algorithm for the same, and we know there is no need of by heart or study all these algorithms. We will go into the problem directly and see how to apply this on into a problem. So here I will be discussing step-by-step process. For example, the given problem is z is equal to function of ABC, a bar BC plus ABC plus a bar B bar C bar plus a bar B bar C plus a B bar C bar plus a B bar C. That is the question. So write down the binary equivalent. So you can identify it. That is first one 0, 1. Next one 1, 0, 0. It is 4 and 1, 0, 1. It is 5. That is the binary notation. So index in the sense I have to categorize this into different categories, like which doesn't have zeros, that is index 0, and which have in the binary combination we have only one 1, that only one binary 1. To clarify, that is in this combination you can see only one binary 1. So this comes under index 1. In the same way, in this binary combination, you can see only one binary 1. So this comes under index 1. So here in this combination, there are two number of binary 1s, isn't it? So this comes under next index, that is index 2. And finally, here we can see the decimal equivalent, and usually we prefer column for first column which represents the index. So write down index 0 and the decimal equivalent is 0. Next is the combination, that is 0, 0, 0. That is 0, 0, 0 is written. After that, put a line, indicate that you don't have any other combinations in index 0. So next, coming to index 1, first one is 0, 0, 1. Write it down here, 0, 0, 1 corresponding binary. And next one more is there in index 1. So that is 1, 0, 0. That is the binary 4. Write it down, 1, 0, 0. Next, so put a line again so that we can understand that here the combination in index 1 is completed. Next, move on to index 2. So in index 2, we have 1, 0, 1. Here we can see 1, 0, 1. So it comes in index 2. This is the first step. So what we have to do first, once we get the question, identify the binaries corresponding to that combinations and find out the index depending upon the number of zeros, number of ones present in the binary combinations. So each binary combinations you map into the particular index. First, you have to find out the number of index. For example, in this case, we have 3 index, that is index 0, index 1, and index 2. So I have the 1, 2, 3, 4 combinations in the question. I have to map all these 4 combinations into the index depending upon the number of ones present in the combination. That is the first step of Quine Mcklausky. Hope this is clear. Until this, it is clear. So, sir, next moving on to the second step. In the second step, I need to compare this, like this index 0 with index 1, index 1 with index 2. You cannot compare index 0 with index 2 because you have 2-bit change there. Only 1-bit change can be acceptable and it can be compared. So first I need to compare 0 with index 0 with index 1. So I compare 0, 0, 0 with 0, 0, 1. That is 0 and 1. If I compare the last term, or here you can make out the change. It is from 0 to 1. So you can mark it as dash. That is when you compare 0 and 1, you get first 2 bits are same and the last one is changed. So it is marked as dash. And next, if you compare again, that is 0 and 4 you should compare. So first bit you have the changes, rest 2 are same. So first you will get dash and next is 0, 0. So once we finish this comparison completely, since 0 is compared with 1 as well as 4, so we have to put a line there so that we have completed the comparing of index 0 and 1. So here we can see that we have the line, and whenever we are comparing, note the decimal values in the bracket. The first one is 0, 1 and next one is 0, 4. In the same way, next we need to compare index 1 with index 2. That is, first let me take the decimal 1, that is 0, 0, 0, 1 with 1, 0, 1. See here these two are same. Only changes we can notice in this first bit. So that is dash 0, 1. 1 and 5 dash 0, 1. That is the next. Which one we need to compare? So here 1 and 5 is done. Next remaining is 4 and 5. So 4 and when we compare 4 and 5, that is 1, 0 is same. The last bit is changing. So that is 1, 0 dash will be the, should be written here 1, 0 dash, and we have to write the decimal as 4, 5. First one, it is 1, 5. Now we got the second list over here. Hope it is clear till this. That is what we have to do in the second step. I repeat, first we have to check index 0 and then compare it with index 1. That is, all the combination in index 0 should be compared with all the combination in index 1. Once we complete this comparison, note it down along with the decimal values. If at all any change is observed, that change should be marked as dash. Only one change should be considered. If you have more than one changes there, you have to neglect the or discard that comparison. Those things we will check in the future problems. Next, since we finished with index 0 and index 1 comparison, then we have to move to index 2. So index 1 should be compared with index 2 and note down the corresponding comparisons, what you get. So here we finished with the second list. After finishing the second, we have to move on to the third. What should be done in the third? So here we can see the second. We have to compare this one with this in the third list. So 0, 1 should be compared with 1, 5 as well as 4, 5. In the same way, 0, 4 should be compared with 1, 5 and 4, 5. Now check 0, 1 and 1, 5. See, first bit you have changed. Second is same. Third also you have changed. So you cannot compare that. So discard that. 0, 1 with 4, 5. Check. First bit you have changed. Second and third is same, isn't it? So 0, 1, 4, 5. What you get? First one you have changed, that is dash. And the second one it is 0. And third one is already dash. So 0, 1, 4, 5. Tick it out. Okay. You have compared 0, 1 with 4, 5. So put a tick mark over there. So you can understand you have compared this. Now coming to the, so 0, 1 is compared, 0, 1 you checked with 1, 5 as well as 4, 5. So 1, 5 it cannot be compared, so discard it. And 4, 5 you compared, so you have put a tick mark over there. Zero, 1 I have put a tick mark. 4, 5. Now remaining 0, 4 I have to compare with 1, 5. 0, 4 with 1, 5 and 0, 4 with 4, 5. So check whether 0, 4 can be compared with 1, 5. The first one is dash, next one is 0. Here you can observe the change. So you can mark this as dash. So 0, 4, 1, 5 you can compare. So you can put a tick mark over there. Dash, 0, dash, and next 0, 4, 4, 5. Can you compare that? No, it is not possible to compare because you have more than one bit change over there. Already they are included in, you have put a tick mark. They are compared, so it doesn't matter. So this is the third list. Hope you understood. If I repeat, like once you get the second list, start comparing the combinations in this with the combination in this. All the combinations in both the sets should be compared, and make sure that when you are comparing, you have only one bit change. If at all you notice more than one bit change, discard that. So here, check the decimal, that is 0145, and both are same, isn't it? This as well as this, both are same. So what will be the corresponding? You don't have, what is the meaning of this dash? Means you don't have that term. That is, so I can say B bar is the simplified form of given Boolean function, this function. I can also cross verify by using K-map. See here, that is 0, 1, 4 and 5 is given. So if I can group all this together, that will be B bar will be the answer. So in this way, you can cross verify that using K-map. So let me show you one more example, that is f equal to summation m0, 1, 2, 5, 6, 7. So I have note down this, all the minterms over here, and the corresponding binary is written. And once I completed writing the binary, then I have to map into the index. So in this, 0 is the comes under index 0, and 1 means it will be having one binary 1. So it is 0, 0, 1. Next 2 means it will be having 0, 1, 0. This both comes under same index. And 5 you have 1, 0, 1, and 6 it is 1, 1, 0. So this both will come under same index. So I can put a mark over here. This is index 0 and this both has two number of ones. So it is index 1 and this both has, sorry, and this one also has, till this it has two number of ones. One number of ones and then two number of ones. So till this. So in this way, that is, I can group as index 0. This one is 1. This one is 2. And this one is 3. In this way, I can group. So once you get the binary, so in this we have three number of ones. So that comes under index 3. So I have grouped everything. Now what is the next step? I need to compare. So first one, I need to compare 0 with 1. So 0, 1. So here you have 0, 0. The last bit is changing. So that is dash, 0, 0, dash. And again 0, you need to compare with 2. So 0 and 2. Middle bit is changing. So that will be dash and rest both the side it is 0, 0. 0 dash 0 will be there. And next, see, compare index 1 ends here, isn't it? So you cannot compare this with 5. So I have to mark a line over there. 0, here it finishes. Now again, 1 should, index 1 should be compared with this 2. So 1, you have binary combination 0, 0, 1 with 5, 1, 0, 1. So first bit you have changes, rest it is 0, 1. So 1, 5, write down the decimal and then mark dash 0, 1. So once you compare, put a tick mark, that is 0 you compared with 1 and 2. Now 1 you compared with 5 and 1 you have to compare with 6. Check it out. 1, 0, 0, 1 and 1, 1, 0. So you can notice more than one bit change. So you cannot compare them. Now move on to 2. 2 with 5. 0, 1, 0 and 1, 0, 1. See, can you compare that? No, because you have more than one bit change in this case when you compare 2 and 5. So you cannot compare. Now 2, 6. See, here you can compare because only first bit you can notice the change. Rest two bits are same. That is dash 1, 0 will be. So 2 you have put a tick mark. 6 now you can put a tick mark since you compare 2 and 6. Dash 1, 0. Now the remaining is what? That is we need to compare 2 and 3. So 5 and 7. So till here we finished with. Now 5 and 7. Compare 5 and 7. So middle bit is changing. So it will be dash and tick, put a tick mark for 7. Now 6 and 7. The last bit is changing. There is 1, 1 dash. Now you can see all the comparison is done since you have put a tick mark also. Now Next step, check whether you can compare. Third step is we have to compare it again. Check whether you can compare it again or 0 1 with 1 5. So it is impossible because you don't have any similar thing. You can notice more than one bit change over there. In the same way, 2 and 0 2 with 1 5 also can't. 0 1 with 2 6 also cannot be done. 0 2 with 2 6 also cannot be done. The same way 1 5 and 5 7 cannot be done. 1 5 and 6 7 it is also cannot be done. 2 6 and 5 7 cannot be done. 2 6 and 6 7 also cannot be done. So this is the last option. Now what we have to do, we have to put a prime implicant charge because we have so many terms over here, isn't it? For each case you will get some terms over here. If I write it, that is if I write it, what will be, if I choose this as a small letter A, this one is B, C. A bar, this one B bar, this is A bar, C bar, this one is B bar C, B bar C, and this one is B C bar, this one is A C, and the last one is A B. This will be the terms corresponding to given or obtained combination over here after comparing. Now to find out the minimized form, we have to use a prime implicant chart. So what are there? See, all these terms should come over. We have to write it over here, and all the terms what we obtained here, we have to write it over here. That is A bar, B bar, A bar, C bar, B bar, C, B, C bar, AC and AB, all this. And check it out now, whether any, in the check column wise, whether any you have any of this have a single check mark. So how to put this check mark? Like first one, A bar, B bar, that is it is representing 0 and 1. Put a check mark over 0 and cross mark over 1. And the same way for 0 2, put a 0 2 we obtained from the corresponding combination over here when we compare. So put a cross mark for 0 and 2. The same way 1 5, this one is 2 and 6, 5 and 7, and 6 and 7. Now check in the column wise whether you have only one single cross mark, nor has two cross marks. You cannot notice any single cross mark. So for example, if I choose this A bar, B bar, then let me take a pen. So if I choose this one, then it covers this column and this column, isn't it? See, you have two check marks, and the same way it covers this as well as this. Now next I should cover 2 5 6 7. So check which covers 2 5 6 7. It covers 2, but it covers again this also, which is not required because already it is covered, isn't it, in the first term. Next 2 is covered by this one. So if I choose this one, it covers 2 and 6, isn't it? So 2 and 6, it is done. Now remaining is 5. For 5, I have to choose either 1, 5. That means 1 is already covered, so which is not needed. So move on to the next. That is 5, 7. That is remaining. 5 and 7 is remaining. So you can choose 5 and 7. That is the third term. 5 and 7. All the min term has been covered by one or the other terms over here. So this will be the minimized form. That is a bar, b bar plus b, c bar plus ac will be the minimized form of this given function. But in this we have alternate solution also, because it depends upon how we choose. So let me tell you one more solution for the same. That is a bar, b bar, a bar, c bar, b bar, c. The same thing it is written over here. Now if I choose a bar, c bar, that is a bar, c bar. If I choose this one, it covers 0 and 2, isn't it? 0 and 2 is covered. Now what is remaining? 1 is not chosen. 5, 6, 7. So 1 and 5, I can choose this one because 1 and it covers 5 also. So I can choose this one, b bar c. So it covers 1 and 5. Next, which one is remaining? 6 and 7 is remaining. Check out which is representing 6 and 7. 6, it is represented by BC bar, but it represents 2, which is not needed. Next is 7 is AC. 5 is already, it covers, it is already included. Now 6 is 7 is the last one, that is AB. So it covers 6 and 7. So in this way, this is the alternate solution. F equal to a bar c bar plus b bar c plus ab. The previous case, that was a bar b bar plus b c bar plus ac. The solution depends upon how you choose the min terms by with the help of the prime implicant stars. In the same case, you can also get two solutions in case of K-map. If you cross verify by using K-map also, we can understand that we will be having two solutions. So here we can see that is 1, 3, 1, 2, 0, 1, 2, 5, 6, 7 are the combination. I have marked it, and for grouping I have given the same shades for ones. So this and this comes under same group. This two can be grouped together and this two can be grouped together. So if we group in this way, then we will get a bar c bar plus b bar c plus ab. In the same way, if I group in this way, then I'll get the alternate solution, that f equal to a bar b bar plus b c bar plus ac. Both are correct. We cannot say that is wrong, this is wrong. Both are correct answer for the given problem. Hope you understood how to solve this Quine Mcklausky. For the more further problems, we will discuss in the next lecture. So here we can see the more number of literals, that is f of a b c d. It is done for the 4 literals, that is from starting 0 to 15. The question is f of a b c d equal to 0, 1, 2, 3, 5, 7, 8, 10, 12, 13, 15. So make the list of the first indexes and write the combinations binary combinations over here and map that into the particular index. 0 comes under index 0, and next number of 1, binary 1 you have in 1, 2 and 8 you have only one binary 1 over there, so it comes under index 1. Next is index, this is index 0, this is index 1. Next is index 2, which consists of two binary number 1s. Here you can see two binary number 1, that is 3. Next, two binary number 1 in 1010 case, and 101 you have two binary 1, that is 3, 5, 10. Next is 12, 1100. So all this comes under index 2. And next is three binary ones. So check, see here you can see three binary ones, that is 7, 0, 1, 1, 1. Next is three binary 1, you can see here 1, 1, 0, 1. That is 1, 1. It is 0. This is, make sure that it is 0. Don't get confused. And 1, 1, 0, 1. And the final is remaining is, this comes under index 3. 4 number of ones, which comes under index 4. That is 1, 1, 1, 1. So in this way, we can map the combinations into index. Now we need, what is the first step? We need to compare. So first I have to compare this 0 with 1. So make a note over there, check whether it is possible to compare. Yeah, it is possible to compare. The last bit changes. So 0, 1 is compared. This, it is 0, 0, 0 dash. So I can put a tick mark for 0 and 1. Next 0 and 2, it can be compared, 0, 2. So 0, 0 dash 0. So I can put a tick mark over here. 0, 0 dash 0. And next 0 and 8. Yeah, first bit you can notice the change, rest everything it is 0. So that is a, sorry, I have to put a tick mark over here, 8. Next we compared index 0 with 1. Now I have to compare 1 with 2. So for comparing 1 with 2, compare 1 with 3 first. Decimal 1 with decimal 3, that is 1, 3. What will be the answer? 0, 0, 0, 1. Here it is 0, 0, 1, 1. So you can see that third bit is changing. So third bit will be dash, as rest everything will be same, 0, 0 dash 1. So mark a tick mark for this. And next is 1, 5. That is 0, 1, 0, 1. So I think second bit is changing over here. You can notice it from 0 to 1. Rest everything it is 0, 0, 0 dash 0, 1 will be obtained. 0 dash 0, 1. I have to put a tick mark over here. Next, what I need to compare? I have to compare this 5 with 10. Sorry, 1 with 10. That is 1, 0, 1, 0 with 1, 0, 1. So it is impossible because we can notice more than one bit change. In the same way, 1 with 12, it also cannot be compared because first 2 bit changes you can notice there. So it can be discarded. Next, you have to compare 2 with 3. 2 with 3 means it is 0, 0, 1, 0 with 0, 0, 1, 1. So when we compare, third bit is changing. 2 3 0 0 1 dash. So it is already take, and 2 with 5, 2 with 5, 0 0 1 0 with 0 1. See, this bit is changing. Again, this bit is changing. So 2 with 5 we can discard. 2 with 10. First bit you can notice change, second bit same, third bit same. So 2 with 10 you can compare, and you will get 0 dash 0 1 0. And the next 2 with 12. It cannot be compared because first two bits are changing. Now next, move on to 8 3. 8 3. Compare 8 and 3. So many bits are changing. It cannot be compared. 8 with 5. More than one bit change you can notice. So cannot be done. 8 with 10. 1 0. Yeah, 8 with 10 you can compare. So that is 1 0 dash 0 will be the answer. 8 with 12 you can compare. So we put a tick mark over here to where you have compared with 8, and you will get 1 dash 0 0. And next what you have to do, you have to compare this with this set, that is 3 7. The same way you will get 0 dash 1 1 and 5 7. Same way we have to compare, like 5 and 7. What was changing over there? Third bit is changing, so it is 0 1 dash 1 5 7. So put a tick mark. 5 you have already put a tick mark. Put a tick mark to 7. Next 5 13 you will get dash 1 0 1. Put a tick mark to 13. Next check 10 with 7. It cannot be compared. 10 with 13 cannot be compared. Next is 12 with 7 cannot be compared. And 12 with 13 you can compare it. The last bit changes, that is 1 1 1 1 1 0 dash. So put a tick mark to 13. It is already, you have a tick mark over there. Now the last option is you have to compare this set with this one. So 7 and 15 you can compare it because you have only one bit change over there. So put a tick mark to 15 dash 111. And 13 and 15 also you can compare 1 1 dash 1 will be the answer. So this is the second list. So when the number of literals goes on increasing, the Quine Mcklausky becomes lengthy. So you have this much sets of combinations in second set. Now we need to compare each. Again 0 1 with 1 3, 0 1 with 1 5. In the same in that way we need to check 0 1 with 1 3. You cannot compare 0 1 with 1 5. 1 5 also cannot be compared. Again 2 3. Yeah, you can notice this bit change over 2 3. So put a tick mark 0 1 with 2 3 and note down the next combination, that is 0 0 dash dash. Next is 0 1 with 2 3 2 10. No, 0 1 with 2 10 cannot be compared. 0 1 with 8 10 also cannot be compared. 8 12 also it cannot be compared. Now check for 0 2 with 1 3. 0 0 dash. Yeah, 0 2 with 1 3 can be compared. 0 0 you have 0 0 here dash dash, and the last bit change, so it becomes dash dash. So 0 2 and 1 3 here. 0 0 dash dash. The same way 0 0 0 2 compared with 1 5. Can it possible? No, it is not possible. 0 2 with 2 3 also it is not possible. 2 10 with 2, 10, it is not possible. 0, 2 with 8, 10, it is possible. So note it down. The first bit you have changed over there. Second is 0 and third is dash 0. So 0, 2 with 8, 10. Put a tick mark over this. Dash 0, dash 0. That will be the combination for 0, 2, 8, 10. Now next 0, 8. 0, 8 can be compared with 2, 10. First one it is dash, rest everything it is. So this bit is changing over here. So dash 0 will be the, so put a tick mark for 2, 10. That is 0, 8, 2, 10. Now hope everything is done over here. 0, 8 we already included. 2, 10. Now 8, 12 is, we didn't compare that 8, 12 with any of the, it is not possible to compare. So leave it there and start comparing this set with this set. The same way 1, 3, 3, 7. Check 1, 3, 3, 7. It cannot be done. 1, 3, 5, 7 can be done. So note it down. 0 dash dash 1 will be the, put a tick mark for 5, 7. Next is 1, 5, 3, 7 can be done. So we will get 0 dash dash 1. So put a tick mark for 3, 7 here. Next is 5, 13. 5, 7, 13, 15. So next, I think everything, rest everything cannot be compared. So moving to the next two sets, that is this one comparing with the last set. So 3, 7 with 7, 15 cannot be done. 3, 7 with 13, 15 cannot be done. 5, 7 with 7, 15. 5, 7 with 7, 15 cannot be done. 5, 13 with 7, 15. 5, 7 with 13, 15. 5, 7 with 13, 15 can be done. Here you can see 5, 7 and 13, 15. You can notice only one bit change. So that 5, 7, 13, 15 dash 1 will be the answer what we get when we compare. And next 5, 13 can be compared with 7, 15. See, we can notice only this bit change, rest everything will be same. So notice down that is dash 1 we will get. Put a tick mark over 5, 13 and 7, 15. So hope we have all the tick marks except this combination, that is 8, 12 and 12, 13. So note down now here, you can avoid the same thing will be obtained. So here you can choose only one, that is a bar, b bar. The same thing over here, that is b bar, d bar, and it repeats over here, a bar, d, and this one is bd. So here what we have to choose the prime implicants, that is a, c bar, d bar, a, b, c bar, because these two are not included in any one of the comparisons. So it will left without a tick mark. Because of that, I have to choose those things in the my prime implicants chart. So note down all the min terms and the combinations what we have obtained. So those combination I have to write in here and the min terms over here, and then a bar, b bar, it is, check it out. What are the combination? A bar, b bar, 0, 1, 2, 3. I have to mark it a cross mark, 0, 1, 2, 3 over here. For b bar, d bar, it is 0, 2, 8, 10. That is 0, 2, 8, 10. And next a bar d, it is 1, 3, 5, 7. A bar d 1, 3, 5, 7. And next is bd. BD 5, 7, 13, 15. So what is that? 5, 7, 13, 15. And next A, C bar, D bar. What are the combination? A, C bar, D bar, 8, 12. Note it. 8 and 12. And the last combination it is A, B, C bar, that is 12 and 13. A, B, C bar, that is 12 and 13. Now check the essential one, that is only single mark in the column. Check all the columns, column wise, so all have 2 markings. But in case of this 10, this min term 10 can only be covered by this B bar, D bar, isn't it? Rest everything, you don't, rest all the min terms, those they don't cover this 10. So we have to, this one we have to choose that as the essential one. And for 15, it is covered by this only. This only. So I have to choose this because you don't have any other check marks over here. These two are very essential one. So if I choose this, put a tick mark. This one and this one. If I choose this, which all are covered? 8 is covered and 2 is covered, 0 is covered, isn't it? And if I choose this one, 13 is covered and 5 and 7 is covered. Now which else is remaining? 1, 3, 12 is remaining. One, 3. See, I can choose this A bar, B bar. So it covers 1 and 3. A bar, B bar. It covers 1 and 3. And now remaining is 12. 12 means I can choose either A, C bar, D bar or A, B, C bar, anyone. If I choose A, C bar, D bar, so many alternate solutions are also there. So if one solution is B bar, D bar plus BD plus A bar, B bar plus A, C bar, D bar. Either I can choose this to cover A bar, B bar to cover 1 and 3, or also I can choose some other, that is A bar D to cover 1 and 3. So you have A bar D. You have so many minimals, so many solutions. You can check it out. So I have verified that the same thing using my K-map, that is 4 variable K-map. I have obtained this answer. So please subscribe my channel for the PPTs you refer. Give the blog details or blog link is given. Please refer that. Thank you.